All right, welcome everybody. We're just kind of letting the waiting room trickle in here, and then we'll get started. Apologies for the 4-minute delay here. We had a couple technical difficulties that we just got worked out. So welcome to this online workshop. You are currently at a workshop to discuss a recently funded Nature Conservancy project to the University of Florida. The title of which was A Holistic Assessment of Using Shellfish Aquaculture for Water Quality Improvement Initiatives in Florida. So that is the title of today. If you're in the wrong place, feel free to drop off at any time. I've got the agenda up on the screen here, so you can kind of get an idea of how the next hour and a half is going to go. But just Zoom logistics, I think we're all pretty familiar with Zoom at this point, but make sure your microphones are muted unless you want us to hear you. Cameras are optional for audience members. We encourage our speakers to leave them on, and you can have your camera on if you like, or turn it off if you want. That's fine too. Just so you know, we will have time after each one of the presentations for some Q&A with the audience. So after each presentation, you'll have a chance to ask that speaker some questions. And then we'll again have some time at the very end to engage with the speakers. Another thing that happens during these online workshops is you see a lot of activity in the chat. You can rest assured that we will save all of that information, and everybody that's registered for this workshop will receive a follow-up email after the workshop concludes with all of the information that's presented today, including all of the relevant links and resources that might be presented in the chat. So with that, I'm just going to kind of jump into it here and give you a little bit of background on what we're going to talk about today. My name is Angela Collins. I'm with the University of Florida and Florida Sea Grant, and I'm based at the UF IFAS Tropical Aquaculture Lab. Today, this workshop is basically to summarize the findings of a 2-year grant that was funded through the Nature Conservancy looking at shellfish aquaculture and its role in water quality improvement initiatives in the state of Florida. We really wanted to have this online workshop to engage with stakeholders like you guys and to gather feedback that can help inform future efforts for research and extension with shellfish aquaculture in the state. So a little bit of background on what the Nature Conservancy SOAR program is. This is actually a program that began by the Nature Conservancy around the time that COVID occurred, and a lot of the shellfish producers across the country were significantly impacted by the market closure. SOAR was created to support these struggling farmers by purchasing some of the unsaleable live oysters at that time and using those in restoration projects and other avenues. SOAR actually stands for Support Oyster Aquaculture and Restoration, but us here in Florida, we think it should be called SCORE because we're also talking about clams as well as oysters. So the TNC SOAR program expanded in 2021 to shellfish growers and other aligned organizations to help some of these marine conservation efforts and increase economic potential for shellfish aquaculture and shellfish farming in the U.S. So the program had 5 key priorities, and those are listed there on the right side of your screen. And our project actually targets these first 2 right here, advancing payments for ecosystem services and also looking at long-term markets for restoration. So our project team was full of wonderful faces, and this is all of the folks that were involved in this effort. And I'd like to specifically call out that bottom right corner, which is the Florida shellfish farmers. All of these guys were actually, critical and instrumental in gathering the data and the information that made this project move forward. So the 3 kind of main points of the grant were basically to look at this trifecta. We're going to hear from Tom Ankersen about the legality and policy surrounding the implementation of a payments for ecosystem services plan in Florida. Then we're going to hear from Kelly Grogan about the economic viability of advancing a nutrient credit trading market in our state. And then we'll hear a little bit from Ashley Smyth on the science behind it all. She's going to discuss her research that focused on quantifying some locally relevant denitrification rates at shellfish leases in Florida. So again, the overall objective of this work is to enhance the economic and ecological sustainability of shellfish aquaculture in our state specifically through an improved understanding of the ecosystem services that these clam farms and oyster farms may be providing. We all know that shellfish aquaculture is awesome, and we want to continue to help explore ways for Florida's industry to expand through these legal, economic, and biogeochemical lenses. And it's hopeful that some of this work will help develop potential alternate revenue streams for Florida shellfish farmers and advance the payments for ecosystem services plan in the state. So without further ado, I'm going to go ahead and introduce our very first speaker, Tom Ankersen.
Okay, are folks seeing my screen?
Yep, we got you.
Okay, then here, I'll get this bigger and get started here.
And
Thanks,
Tom,
everyone. It's great to be able to sort of bring this to a conclusion and work through the issues that we've been working on over the last couple of years. You'll recall we had a workshop last October addressing some of these issues, particularly as they relate to restoration aquaculture, and went through in some detail some of the jurisdictional questions relating to which agency, why, and how. I'm going to kind of gloss those over to look more at this this issue of how to fund ecosystem service payments. So that's where I'll work through.
Here's hey Tom, can you put it in presentation mode?
Let's see here. Where do I do that?
The bottom right corner of your screen, there's a thing that looks like a slide. Yeah. There you go.
That it?
It's okay. Oh.
What did I just do?
That's okay. We see your notes page now.
Yeah,
so
I know.
You can just go back to the way you had it. Was fine.
Yeah, except that thing's not popping up. Let me try this. How's that?
Perfect. Perfect in every way.
Now I got to push buttons differently. Anyway, so I'm sorry. I'm going to kind of gloss over these jurisdictional questions a little bit, and we can discuss them in greater detail, and we'll present them in greater detail in our final report. Talk a little bit about the bigger picture planning that the aquaculture, the FDAX is doing, the Division of Aquaculture, and then get into the different types of ecosystem payment possibilities there are for, in particular, for bivalve aquaculture, and then I'll go through some conclusions and recommendations. So just to remind everyone, what we're dealing with is our activities on sovereign submerged lands. Typically, these are lands that are owned by the state, and there are competing interests for how those lands get used, and whether who can preempt the use of that land and why and how, and that is administered by the governor and cabinet, and both Department of Environmental Protection and Department of Aquaculture, Agriculture and Consumer Services effectively staff that those activities. And this is all subject to a public interest test, which has got a heightened standard for aquatic preserves. I'd point out that there are non-state-owned submerged lands, quite a bit more in the state than people sometimes realize, and that those are privately owned, and perhaps there's more flexibility there to do some sorts of payment programs, but there still may be some overlays that from permitting and even a public trust perspective. In terms of, so what's driving all this? It's all being driven by the Clean Water Act, Section 30D, which requires states to designate impaired waters and then begin to do something about them. That process has been delegated to the state of Florida, and it requires the state to, once it has designated waters as impaired, identify the total maximum daily load of pollutants, in our case, nitrogen and phosphorus, for example, for that water body, and then to take action. And that action comes in the form of a basin management action plan, or something analogous in some areas called a reasonable assurance plan. That plan is identified under the statute as a framework for water quality restoration that contains local and state commitments to reduce pollutant loading through current and future projects and strategies. And aquaculture can certainly be one of these strategies. And I'd also note that a number of estuarine systems and tidal creeks have not been designated as impaired procedurally, and then hence they have no TMDL, and therefore no basin management action planning process underway. The process is under constant review and iteration, but that is a fact. So in terms of the planning framework, I'm just going to highlight the state aquaculture plan. So this plan is mandated by the legislature, and it's done every year. And we've looked through the sort of the history of it. I did with some help from our friends at FDACS providing these planning documents. The first reference to restoration aquaculture for nutrient management came in 2020. That was amplified and became more specific in 2021. And basically, this drives the funding from the state to work on these sorts of projects. And it says conduct program development for bivalve, shellfish, seagrass, fish, and other aquaculture species to be used in nutrient mitigation, nutrient credit, nutrient trading, or similar conservation restoration programs. And in 2022, they added seaweed to that mix of possible areas. So we'll get right into what we're here to talk about, which is payments for ecosystem services. There'll be a lot of discussion about nutrient credit trading, but I'd like to just point out that these are not the only way that ecosystem services can be paid for. Credit markets is certainly one of them, but it can also be done through something called fees, and particularly user fees. It can be done through taxation, and it can happen through grants and subsidies, and I'll give you some examples of each of these. So the forms of payment, we'll talk first about the nutrient credit markets, and I'll work you through the nuts and bolts of the statute and the regulations. This is based on the principle of cap and trade, which has worked very successfully in terms of air pollution control policy, in particular in the United States. And what it does, and it's this idea of trading at least, is to reward those polluters that reduce their discharges below an allocation in their permit, and they can trade or sell that reduction in a geographically defined market as long as the cap that was established is not exceeded. It can also be, so that's a trade. So you have two polluters, one polluter trading with another based upon their relative amounts of pollution. But it can also be work as a way in which an entity that is not a polluter but is actually generating a net benefit can generate credits and sell those and or trade those presumably, but I guess sell would be the more likely prospect. And this looks more like a mitigation bank. And we've talked about mitigation banks in the marine environment just recently with seagrass, and there was some legislation attempted that did not pass muster. It failed in the legislature with some opposition from any number of groups and also even within the state. It's been harder to sort of contextualize this idea of credit trading in the context of water pollution generally, but especially in the case of non-point source water pollution, such as agricultural runoff and stormwater runoff, which is much of what is causing the issues in Florida's waters. So there's quite a bit of literature, scientific literature out there on how you calculate the credits and the difficulties in doing that and so forth. Nonetheless, it has been promoted as a way to provide payments to bivalve and other aquaculturists in the marine environment. So this is going to be kind of boring, but I'm going to push you through it. This is the statute that authorizes water quality credit trading in Florida. It was passed in 2008, I believe, and it could work, I guess, is my bottom line. It could work in this context, whether it should work or does, or how it will work is a different question. But basically, we're talking about the sellers, in this case, our clam farmers and so forth. And they're responsible for achieving the load reductions that they're going to sell sell to buyers in the market. And that moves you into rulemaking, and the DEP has a rule which authorizes this. And did I miss a slide? Let me see here. Yes, I did. I'm sorry. As we're going to show you, it is possible to calculate with some precision the nutrient sequestration and removal benefits that clam aquaculture provides and assign it a theoretical monetary value. There's an active program in Chesapeake Bay, but as we learned at our workshop in October, after 6 years of research and development, there have only been 2 aquaculture-based trades. Florida has a more generalized nutrient credit trading program, which is what I was just describing. That program began in 2008 in the lower St. Johns River Basin. It was expanded in 2013. There's only been 4 trades recorded. All of those are in that initial basin, and none since the statewide expansion. So you can see there's been a lot of reluctance to move in the terms of the markets to move in this context. So back to that, and then now we'll get into the rule. So here are the general requirements. Credits may be traded only with the boundaries of a BMAP or a RAP and a reasonable assurance plan. That's a constraint already. There is a sort of a little bit of wiggle room with hydrologically connected waters, but you've got to have that impaired water, that TMDL, and that basin management action plan. The other issue is we're dealing with non-point sources, which the statute seems like it was set up more to deal with point sources, trading between point sources, but you can do non-sources. MS4 is a municipal stormwater treatment permit. They can be estimated. In fact, that's pretty much how it would work. And if they are, the DEP will use what are called uncertainty factors to adjust the credit available, and that's where we could get into some difficulties. In terms of credit eligibility, this is where you have to look, well, can aquaculture, can clam or oyster aquaculture be eligible to create credits? And it looks like it can. Water quality enhancement production practices are certainly that. And management practices with a demonstrated ability to reduce nutrient loading. So they would be eligible. There's a pre-approval process, which goes to DEP. So the generator, that would be the farmer, must submit information to the department describing the activities and the expected load reduction below the generator's baseline. The baseline would presumably be 0 here, since they're not a polluter. And you'll see the calculator at the end that would actually produce some of this information. Then there's this question of location factor, and this is problematic too, because basically the idea is to try and have the polluter who's buying the credits be close to the seller who's selling the credits, so the pollution is offset. So the farmer would have to be in the same general area, and the further they are from the area where the pollution, the discharges are coming, the more likely the DEP would be to use this factor to reduce the value of the credit. And then there's the uncertainty factors. For estimated credits, there's a default ratio of 2 to 1, and then after that it becomes negotiated, and the DEP makes a decision based on their site-specific determinations. And so here are the 4 trades that have happened. I guess they're all in the same basin. 3 of them are trades. 1 is a sale. Only 1 is a non-point source, and that was an estimated non-point source, and that was a trade. So this is the registry that DEP is required to have by the legislature. So here's some of the issues. They may work for bivalve aquaculture, but it wasn't designed with that sort of project in mind. The requirements that trades occur in the same paired water body is a constraining factor. Location uncertainty factors are problematic. And then there are, after all, what can go wrong? And everyone knows all the things that can go wrong just being in the marine environment, from hurricanes to red tides to so forth and so on. And then there's quite a bit of monitoring and reporting during the period that the credits are available. There's a duration, and that has to be sort of factored in as a transaction cost. The next one, I'm going to blow through these. I'm sure I'm running short on time. Is fees, and so there's a distinction between taxes and fees in the law. I'm not going to get into that, but it's worth knowing. Fees are generally based upon paying back something that is a cost that's incurred as a result of an activity happening, a specific activity, whereas a tax is more general. One place to look might be stormwater fees. Another place to look might be user fees, and I've looked a little bit more closely at the fertilizer fees. We talked about boat ramps and ramp fees, both boat licenses and ramp fees. And then there's also special purpose districts, and this could be taxes or fees. Water and sewer districts often might be an example of that, particularly if they're independently created. Then in taxes, there's an Everglades pollution tax that's interesting, but it was created by a constitutional referendum. There are these special purpose districts, as I mentioned. There's tax increment financing at the local level, and then there's local sales tax initiatives, something else we batted around. Utility fees, they could work. I've talked to an attorney in Tampa who's a former student, and she thought that it was quite possible that they could help fund payments for ecosystem services for a service being provided to reduce the nutrient loading by compensating for it through aquaculture. Location, same issues with location, but I think it's at least legally viable. This is interesting, and I started to drill into this a little bit. The fertilizer fees, there's a whole bevy of them. In Florida, the one of greatest interest is this nitrogen and phosphorus fee. Sounds perfectly relevant, and in particular, the 50 cent per ton. And this 50 cent per ton is deposited into a general inspection trust fund, and it's annually appropriated pursuant to a memorandum of understanding between FDACS and FDEP. So there's a mechanism, there's a fund, it's renewed every year. So if these agencies wanted to pilot this might be a way to do it, and have a continual source of funding for ecosystem services provided by aquaculture. And there is how those funds get used, and clearly aquaculture would fit within that use of funds, implementation measures, BMPs, etc. Local tax initiative, I looked at that. I think that's problematic because the key term is infrastructure, what the statute that authorizes these. It allows local governments to run these referendums, and you hear about it in land buying and so forth. An ongoing PES, Payment for Ecosystem Services program, would likely not qualify, but the construction of the clam beds and so forth could be arguably be natural infrastructure, and so those could work. There was a project funded in the Indian River Lagoon, $60K. This is a tax-funded initiative. A lot of money going to work on Indian River Lagoon projects. I think this might have been funded elsewhere from Sea Grant. I just can't recall, and maybe Leslie can help us on that and tell us that a little bit later. But they did subsidize clam farmers. It's in this project plan, so that project plan may wrap other funding sources into it in addition to the money coming from tax revenue. So that's what I wasn't sure about. So grants and subsidies, this is kind of the end of the line here. There's a distinction between a subsidy and a grant. I'm not going to get too much into that. It's sort of an interesting one. But the ones that looked kind of interesting to me was the Florida Clean Water State Revolving Fund. And then there's legislative appropriations, Restore Act, and different foundations that could provide money for ecosystem service payments. The Clean Water State Revolving Fund is federally capitalized, and it just got renewed first under the ARPA, I think it's called, from the Obama era when the recession, and now we have some infrastructure money coming from the feds as well. It is typically based on low interest loans, but there are grants something called additional subsidization that's in there, and it describes the relevant project types, non-point source and non-estuary program projects, watershed pilot projects, technical assistance. I don't know, some of those might fit. And then there's something called the Green Project Reserve within the State Resolving Fund for, excuse me, environmentally innovative activities. And there's a percentage of, I think it's 10% of the total has to go to these different subsidization and green project reserves by virtue of the federal government providing the money to the state. So those are possibilities. So I'll conclude here with some conclusions and recommendations. The conclusions: bivalve-based nutrient credit markets have not caught on as a form of payments for ecosystem services in Florida or elsewhere. Water quality trading program would appear to work, the Florida program, but these locational and uncertainty factors loom large, so you might end up with ratios in excess of 2 to 1, which may diminish the value of the credits. Monitoring and reporting, as I said, could be quite burdensome for a clam farmer in particular, relative to the amount of money they would get from it. And it would probably be helpful to have some rule reform, if not statutory reform, to clarify some of this, to advance these forms of ecosystem service payments where you're dealing with non-point sources and you're dealing with these innovative technologies. Stormwater utility payments certainly appear to be legally viable. And again, some of the locational factors are still there, and you'd have to sort of convince the local government to take money out of revenue from something that's already obligated to do stormwater management. Fertilizer fee, I think that has a great potential. It's already there. You're not adding a new fee, and it's just a matter of what's in that program and how badly the state would be interested in doing that, or how much the state would be interested in doing that. I don't think local sales tax initiatives would be a likely source, but it could fund some of the construction construction projects, I suppose. Long-term subsidies and continuing grants like the Clean Water Revolving Fund are also a potential for PES. Here are some recommendations. Always consider including aquaculture as a BMP in any applicable basin management action plan. That drives the funding, these BMAPs. So it's extremely important. We could consider a pilot project within the state program and test its regulatory potential. See how far down the road we can get with it, and whether there's some money to be gotten for it, and if it's worthwhile. And we could use some of these pilot projects that are underway now to just for restoration aquaculture to do that. And then there's, I think, these fee-based strategies, in particular the fertilizer fee, if that's viable, and maybe some special purpose districts might be interested in pursuing this as part of their programs. And then the longer term subsidy and grant based funding strategies like the ones that are already underway through the legislature the last couple of years, either through the state revolving fund or through new legislation. So I'll leave it at that and open it for any questions. I'm not sure how we're going to handle the questions, Angela.
Well, if anyone has any questions, there are 3 ways we can handle it. You can type it into the chat and we'll read it out for you. You can unmute your microphone and just yell into the ether and we'll answer you. Or you can raise your hand with the reaction button. So it's up to the audience.
Well, I see Leslie has clarified that those projects in the Indian River Lagoon were funded through the sales tax.
And I was remiss when Tom, I'm going to give you guys a couple more seconds to think of a question, but I was remiss when I introduced Tom. I didn't really introduce him very well. Professor Ankersen is Director Emeritus of the Conservation Clinic at UF Law, and also with the Florida Sea Grant Legal Program. He's been at the University of Florida's conservation clinic for decades and is recently retired, but still continues to be helping all of us in all things legal as far as a lot of the environmental law goes in the state of Florida. I did pay. Oh, yeah.
Maybe I put everybody to sleep, so maybe we just continue on. And
well, I did paste all of your information into the chat as well as some of the relevant links from your presentation. And Ashley's got her hand raised. Go ahead, Ashley.
I'll ask the question, even though I get a lot of Tom's time. But Tom, given all these options and sort of the difficulty with one direct way to generate the dollars to pay these credits, what one would you recommend we pursue first?
Oh, interesting question. I think without having looked at it further, and I have to the extent that I've asked the question, but I think the fertilizer fee, I mean, it's called a nitrogen and phosphorus fee. So it seems like it's a user fee for people who apply or sell nitrogen and phosphorus based fertilizer. If we're going to be taking nitrogen out of the water, then that seems to be a pretty clear opportunity. I don't know how much money is in that. I've asked the question. It's based on tons. I don't have the memorandum between DEP and FDACS, but I've asked for that too. And I just sort of worked my way into this recently and I haven't heard back.
And I've got another question in the chat that says, what are opportunities or avenues for clam oyster credits on other aquaculture projects?
Not sure how best to answer that. It's all of the above that I just discussed. So I mean, it might be what would work where your particular projects are, and be looking more closely at what the opportunities are locally in addition to statewide.
Okay, and I've got both Scott and then Bose, and then we should probably yield the floor to the next speaker after you two.
Hey, Scott.
Certainly. Hey, Tom, how you doing?
Good.
I guess this is kind of the devil's advocate type of question. What are the potential pitfalls? Thinking of some of the issues statewide with tree banks and some of the other ideas, have you viewed that as well too in this scenario?
Well, I mean, I think the pitfalls go under that get lumped under that area of the uncertainty factor in particular. Kind of what can go wrong, and we know that hurricanes can disturb the production. So if someone's relying on these credits to continue discharging at some amount, if that clam farm isn't producing at that level, then there's going to be some concerns on the department side, and that's why they do these ratios, which is similar to what they do with mitigation. But it's so much harder to deal with the marine environment than it is to put a fence around a wetland. So I think that's it. And you can talk about any number of those factors, including extreme heat, which we finally had this year, and it kind of manifested itself in some die-off. Red tides, I guess the clams survive that, and then they keep growing, so that's probably not as big a one. But current changes, all kinds of things happen in the marine environment that are harder to control, I would say. So the uncertainty factor is how that's accounted for.
Perfect. Thanks, Tom.
And Bose here. I'm sorry, I joined late, so this may be a little out of context, but the remit here has been to look at payment to growers for services provided. The other way of looking at this is that there are water quality mandates, EPA mandates on water bodies around the state. And water quality managers have a kind of matrix of interventions that can be used to meet those targets, or at least work towards those targets. If we're not looking specifically at the payment for ecosystem services to the growers, including the nutrient benefits in that management scenario on a water body by water body basis, is another way of looking at it, I guess. Do you have comment on that?
Well, yeah, I mean, I would sort of put that in. If I think what you're saying is that that managers sort of install these themselves, in order to produce clams and oysters. I mean, that would come under the funding that's available to their particular water body, I suppose, if that's what you're getting at. Or are they going to pay clam farmers to do the restoration, in which case it's going to come out of a general revenue fund that's then allocated to the department, which is then further allocated to the particular protected area, reserve, or water body that's being managed.
Yeah, really just raising those options. I wasn't actually thinking much of the first one that you've come up with, but the second one where water management districts might be paying an entity unknown at this point to provide those services.
And that's where I would say the state revolving fund might be helpful too. The green reserve, as they call it, might be a place, because I mean the key I think for the farmers is going to be getting paid every year, not getting paid once or twice, and that's the whole theory of these credits, the way it works in the marketplace. So, yeah, good point.
Okay. Wonderful. This is good conversation, and I'm going to have to move on to our next speaker. Tom, if you don't mind to stop sharing, and Kelly.
Okay, I got to do that. Let me see if I can get out of here. That's the hard part. Oh, there it is. Okay,
so our next speaker is Dr. Kelly Grogan, and she's an economist with the University of Florida IFAS Food and Resource Economics Department. Kelly specializes in bioeconomic modeling and natural resource economics in general. And she's going to talk a little bit about some of the exploration she did in looking into the economic viability of a nutrient trading program in Florida. Take it away, Kelly.
Angela. So yeah, as she said, I'm talking about the economic feasibility of our shellfish producers entering into our nutrient credit trading markets. And so I'm going to talk both about the supply side. So when are our producers willing to produce these nutrient credits, and the demand side. So when are, say, wastewater treatment plants willing to actually pay for these credits? And I'll start with our supply side. And so I surveyed 359 clam and oyster producers. 59 responded. I know we have some producers in the mix, so if you responded, thank you very much. I very much appreciate your time and sharing your information with us. I want to give a little sense of who is in our sample. So on average, our producers have 3 leases. They span about 12 acres. We can see, however, we've got a big range in our sample. So ranging from 1 acre to 150 acres, so a ton. In terms of experience, ranging from brand new to 30 years, averaging about 10 years. In terms of number of organisms produced, again, a huge range. On average, we've got about 2 million organisms. This will be important in a minute when we're talking about clams. And about 200,000 on average for our oysters. And these numbers are per year per producer. So lots of organisms. Age range averages about 50. Like most ag industries, we've got majority male producers. We've got a fairly educated group. About 50% have a college degree or higher. So this slide is showing their current prices received. And these numbers are important. So if we're thinking about whether our producers are going to enter nutrient credit trading markets, they're going to compare those prices to whatever they're getting now. This is their current opportunity. So is that next opportunity going to be better or worse than what they're doing right now? We see our average prices are a good bit higher than our median. We've got some producers, I don't know what they're doing. They're getting a really high price per clam or oyster produced. Our median ones are probably more in line with what most of our producers are getting, ranging from 5 cents per pasta clam up to 60 cents per oyster. We then asked our producers, how much are you bringing in total revenue? On the right, we've got the, I prefer not to say, totally fine. And then we've got our range here, ranging from less than 10,000 to over $1 million. So we've got a ton of diversity in our scale and revenue that they're bringing in. We see a little bit of a critical mass between about $10,000 and $75,000 in sales per year. We then asked about their willingness to produce clams just to generate nutrient credits. And we asked about 3 different kinds of water. So the first place would be in areas where water is not meeting current criteria to sell oysters or clams for human consumption. And if we're thinking about nutrient credits, as Tom was saying, they're probably going to be in impaired water for them to be able to be sold as credits. So this is most likely where our credits are going to be viable legally. So, and our growers were very hesitant to say they would produce shellfish in these kinds of water. 12 said they needed more information, 6 said no way, 10 said maybe, 5 said yes, I'm definitely interested in producing in this kind of water. We then asked, what about areas where sometimes you might not be able to sell your product? So these might be areas that are prone to red tide events where harvest is stopped for a period of time. In this, we see a shift. We just go back once more, we kind of see a shift over to this left side where now we've got 15 say, yeah, I might think about it, I might do it. We still have 4 that say definitely no, definitely not, and 5 still need some more information. And then lastly, we asked about production where sale of product is always allowed. And we've got, of course, the majority saying, yes, for sure, this is great. This is what I'm already doing. Interestingly, we still have 3 say, no, I would not, even in these conditions, I would not produce nutrient credits. And 3 still need some more information. All right, I then asked them, how much would you need to be paid per organism, per clam, per oyster to produce for credits? And so this table, we've got the first column is that median price that we've already seen. And then we've got how much would you need to be paid if you're producing in water where you can't sell your product for human consumption. Next column where you sometimes can sell it. Last column, well, second to last column where you can always sell it. The first thing to note, no matter where they're producing, they're asking a higher price to sell for nutrient credits than what they're currently getting in the market. And as we would expect, where they can't sell it at all, they're asking for the highest price to generate these credits. I think the higher prices in general are just coming from uncertainty about how this would all work, and probably a fear that if it's a government run trade, that there's a lot of monitoring, a lot of paperwork, it's going to be a hassle. Possibly if they were assured it wouldn't be a big hassle, maybe we would see some of these numbers coming down a little bit. All right, next we converted price per organism to price per kilogram of nitrogen removed. And so we use data that you'll hear about a little bit later about how much nitrogen each individual clam or oyster removes. And we see we have very high prices needed per kilogram of nitrogen removed, ranging from about 1,000 up to almost 10,000 per kilogram of nitrogen. So keep these numbers in mind for about 5 or so more minutes. We're going to shift gears now to demand for credits and looking at wastewater treatment plants in Florida. And so again, we surveyed our wastewater treatment plants. We've got 50 respondents. Some of those respondents had multiple facilities, so we've got more facilities than respondents here. Of those 55 facilities, 20 are in those BMAP areas that Tom mentioned, where we've got strict regulations. 30 are operating under these national pollution discharge elimination system permits that regulate point source pollution. And so these facilities are our most regulated ones. They're the ones that probably will have highest demand for nutrient credits, just given where they exist and what they're discharging into. Again, I'll give you a little overview of who's in our sample. So our plants are processing about 2 million gallons of water per day. We asked them about predicted population change and service requirements in the next 30 years. So as you get more people, you've got more wastewater moving through your plant. And so on average, they're expecting population growth, of course, and so more demand for their services. There's a little heterogeneity. Some said we don't expect any population growth. Some said we would decline. At our max, we've got a doubling of population in 30 years, which is going to be a big strain on that wastewater treatment plant. Our last 2 rows are looking at concentration of nutrients in the water that they are discharging. And I'm going to focus in on nitrogen because that's what we care about for our clams and our oysters. And so on average, we've got about 3.3 milligrams per liter of concentration of nitrogen. We're going to learn in a minute that 3 is a critical threshold. So our average is above that. And then our range is ranging up to 15, which is much higher than that 3 critical threshold. All right, we then asked them about their concerns for meeting future regulatory requirements. We asked about within the next 10 years, and most of them feel pretty good about it, not concerned or mildly concerned. Then next 20 years, we see a little bit of a shift more into that mildly and moderate concerned range. And then next 30 years, we've got very concerned, and these are coming from a mix of population growth and concerns about stricter regulations coming down the pipeline. All right, so then we wanted to figure out how much would they be willing to pay for nitrogen credits. And I spoke to people at Gainesville Regional Utilities who were super helpful. I said, all right, I need $1 per kilogram. Like, what can I ask to get at this? And like, no one talks about that in terms of wastewater treatment plants. But there's a lot of concern in the state of Florida that legislation would put in place that requires every plant across the state of Florida to meet a cap of 3 milligrams of nitrogen per liter and no more. And so a lot of them are thinking about what would it cost to upgrade to meet this requirement. So that's what we asked our producers. If they were emitting at concentrations greater than this threshold, we said, what do you think it would cost for you to meet this advanced water treatment threshold? Not surprisingly, we got a wide range of answers. So these are their costs to upgrade in millions of dollars, and we range from about 50,000 to 90 to 100 million dollars. So tremendous variability in our sample. We then use those amounts, and we know how much water they're emitting. We know their current concentrations of nitrogen. So we know how much nitrogen they would emit in total across a whole year above that 3 milligram per liter amount. And so their options would be to either pay to upgrade, or if they could find credits that are cheaper than the upgrade, then they would buy credits. And so the max amount they would be willing to pay based on their cost to upgrade on average is about $4 per kilogram of nitrogen, or their median is about $3. We do see a bit of a range, so up to 10. But if you recall from several slides ago, we were in the orders of thousands of dollars for our shellfish producers. So wastewater treatment plants have a ton of nitrogen. They're thinking about really big scales of nitrogen, and our shellfish are removing a little bit. Aggregated, they're providing a great service, but just when we think about per individual, and when we compare that to what that clam or oyster is getting in our markets for food, we just can't compete with that opportunity cost of producing for food. All right, a little silver lining. When I talked to GRU, they said they would not entertain credits that were less than 5 years. Ideally, they would be 10 years long. And so I asked all of our respondents, what's the minimum time you'd be willing to make a trade for? And some said 1 or 2 years would be fine. And so this provides some opportunity if you're a shellfish producer and maybe you're a little uncertain and you don't want to commit to this for 10 years, you might be able to find some trading partners who are willing to let you try it out for a year, see how it goes, and then you could decide to re-up or not. We also asked our wastewater treatment plants why they might not want to buy credits. Not surprisingly, cost is the biggest issue. Next, they're concerned about the time-consuming paperwork, and then they're concerned about purchasing from multiple sellers to meet their credit needs. When we think about, like I said, the scope of a wastewater treatment plant versus our shellfish producers, there's a big mismatch in our scope, and so that might be a big sticking point as well. And so from this, we can see that our wastewater treatment plants are concerned about meeting future regulatory requirements. This means that probably demand for nutrient credits in the future will increase. Unfortunately, current willingness to pay is a lot lower than what our shellfish producers say they would need to want to enter into these markets. And it's really coming from this mismatch of scale between what's removed versus what our wastewater treatment plants are actually emitting. That is it, and I'm happy to take questions.
All right, folks, same rules apply. Raise your hand or yell or type it in the chat.
Hello.
Hey, Albert, go ahead.
Yeah, so has there been any measurement of what the average amount of nitrogen removal is for farmers in comparison to what they would be getting for credits? And if so, what modeling are they doing to come up with the numbers?
Yeah, I'm going to save that for our next presentation. I think that's literally our next topic. So yeah, great question. We'll answer it for you.
Ashley's going to be directly addressing that topic.
So Kelly, did you address the fact that growers could also sell their product for the price they normally get? as well as then also gain the nutrient credit values.
Yeah, and so yeah, in our
Could you address
survey,
that? Yeah.
yeah, in our survey, we thought it was clear, and it might not have been clear. Will admit that they would be able to still sell it and get that as well. So yeah, I was surprised that then the price they're asking was still more. You would think anything is extra and good. And there was a range, especially for that, where sale is always allowed, where some producers were saying not that much and some were still saying high. So I think our average might be masking that a little bit. And that there were some, like I said, that would have had lower amounts. And so maybe I can follow up if people are interested in with that range and report that as well. So yeah, but I think some of it is, like I said, potentially coming from just concerns and uncertainty about how the market will work and needing to be compensated for that uncertainty as well.
We've got a question. It says, did any of the users indicate how much they'd be willing to pay for the credit?
In terms of the wastewater treatment plants, yeah, so we didn't ask for a specific credit amount. So most of them, as Tom showed, there's only 4 trades that are occurring. And so most of our wastewater treatment plants aren't currently thinking about purchasing credits, and they don't need to in terms of regulatory requirements, which is why we framed it in terms of that cost to upgrade, because it's something that they are probably thinking about given legislative climate and concerns. But yeah, ideally we would be able to get $1 per kilogram if they had that number readily available to provide in the survey.
Okay. All right, Ed Sherwood.
Yeah, hi, can you hear me?
Yep, we got you.
Yeah, it seems like urban stormwater BMPs are on par with the $1 per kilogram nitrogen removal that you quoted for the shellfish restoration aquaculture concepts. Is there any effort to kind of solicit stormwater managers, MS4 permit holders on their willingness to pay for these services, especially if they're looking at like $10,000 per kilogram TN removal of some of the urban BMPs that might be implemented?
Yeah, that wasn't in the scope of this project in the survey that we did, but that's a great suggestion for future work for sure. Yeah, thank you.
Yeah, that's one of the goals of this project, is to look at, get feedback for future priorities moving forward. Go ahead, Bose, and that'll be the last question before we move to Ashley.
Yeah, so I've got a very similar line of question to Ed, actually, is how were the wastewater treatment operators kind of targeted as the only ones that are actually interested in a nutrient credit? Because they are the easy ones to regulate. They are the point sources. It's the kind of, from a water quality management perspective, it's the non-point sources that are the tricky ones to manage. And that's where credits might be even more attractive.
Yeah, for sure. Yeah, they were chosen, as you say, because of their ease of regulation. And so currently they're the most regulated, and then that's the most likely to buy nutrient credits. But if regulations change and they were more enforced for non-point sources, then I completely agree. Then they would definitely be on the demand side for credits as well. And so again, another great suggestion for extension for future work. Yeah.
And I'll just chime in there just briefly that they're the ones that are most difficult. You can measure at the pipe, you can measure the nitrogen. It's much harder. You have to estimate it for these non-point sources, and that's why there's this uncertainty factor of 2. So you already cut in half, assuming the DEP goes with the uncertainty factor of 2. You've cut in half the value of the credit from what it would have been with a wastewater treatment plant.
Okay, great. We're actually going to go ahead and move on and really geek out on the biogeochemistry side of things now. Our next speaker is Dr. Ashley Smyth, and she's actually the PI of this project. She's at the UF IFAS School of Soil, Water, and Ecosystem Sciences Department, and her research focuses on biogeochemistry, microbial ecology, and marine ecology. So she's going to talk a little bit more about all of the nitty-gritty on the nitrogen side of things. Take it away, Ashley.
Thanks, Angela. Thanks everyone for coming too. I hope everyone can see my slides okay, right? We're good? Okay. Thank you, Tom, and thank you, Kelly, for providing us with this overview of the policy landscape in Florida around payments for ecosystem services. We now know a little bit more about what a payments for ecosystem services plan could look like. And we also know how much that nitrogen removal would be worth. But all of this, we can't really move forward until we have the best available science to figure out how much nitrogen is being removed. So I'm thrilled to share with you all today some of the work that my lab has been doing, along with the work of Dr. Shirley Baker's lab, to quantify the nitrogen removal benefits from shellfish. Now, the concept of oysters and other bivalves for being used for nutrient management has gained a lot of attention in recent years. I think I was in graduate school when we were first starting to talk about this, and that was many years ago, if you can tell. And since then, this interest has just continued to grow. We've heard about programs in Chesapeake Bay where they've been pretty successful in having nitrogen removal services traded in markets. And if by pretty successful you mean more than one, then that's what I'm thinking about, as Tom mentioned. But the point remains, there continues to be this forward progress. In fact, just this year in Chesapeake Bay, they released new guidelines that now allow for credits for both aquaculture and oyster reef restoration through the process of denitrification, moving beyond just the bioextraction services that we've been thinking about. Meanwhile, here in Florida, we have DEP beginning to list water management strategies or in-water management strategies as possible solutions or projects for nutrient credits to meet goals in BMAP watersheds. This is really an exciting time, especially if you love nitrogen and you love shellfish. So today I'll share the results from our project that focused on shellfish aquaculture in the Gulf Coast of Florida, where we used field-based and lab-based measurements to really evaluate the capacity of Florida's shellfish to remove nutrients from the water column. These data would be required if there is ever any potential for payments to farmers in a nutrient credit program. The focus of this talk is on aquaculture, both clams and oysters. And to cover what we need to accomplish to convince you guys that nitrogen is removed by shellfish, I've outlined this talk in 3 sections. The first is the justification for using shellfish for nutrient management. The second is results from our study. And then the third will be the assessment of the nitrogen removal ecosystem services provided by Florida's shellfish. And while the focus of our work and this whole workshop is really on, and the whole grant has been on shellfish for water quality, I really do want to stress that they are just a tool in our toolbox, and they're not meant to replace existing on land or other management strategies. Before I dive in, I want to take a moment to thank the huge team of people who've been really helpful throughout this project. That includes our shellfish farmers around the state specialists, extension agents, sea grant agents, other faculty, research technicians, undergraduates, you name it. We have had so many people out on the water, in the mud, and counting clams and oysters. So thank you all. And we couldn't do this work without thanking our shellfish, our Florida clams and oysters. And before we go back to talk about these guys and all the benefits that they do provide, let's first talk about nutrient pollution and water quality. What is nutrient pollution? Nutrient pollution is too many nutrients. This happens when there's an excess amount of nutrients entering coastal systems, and it leads to a growth of algae. Nutrient pollution can happen anywhere. Nitrogen is really the key nutrient that we think of as being a pollutant in coastal waters. And these nutrients can come from a variety of different sources. They can occur naturally as a result of weathering of rocks and soils in the watershed. They can even come directly from the ocean through mixing in currents. And nutrients entering the coastal zones are increasing because of human inputs, where the inputs from our activities are exceeding that of what would happen naturally. This is a result of more and more people wanting to live in coastal areas. As more people move to coastal areas, there's more nutrients that enter, and we're left with our coastal waters having more nutrients. When we get too many nutrients, that's when we get algal blooms, dead zones, and fish kills. Coastal eutrophication, what we can also think of as nutrient pollution, is really a global issue. Estuaries around the world face this, are struggling to combat nutrient pollution. In this map, it's a few years old now, but each red dot shows a waterway around the United States and Central America that has experienced symptoms associated with nutrient pollution, typically hypoxia or low oxygen events. You can see pretty much the entire Gulf Coast and Atlantic seaboard have water bodies that have eutrophication problems or are suffering from nutrient pollution. And when we have nutrient pollution, that's when we have those algal blooms and all the other associated negative consequences, like those dead zones, like fish kills, turbidity issues that affect sunlight, that affect seagrass, leading to habitat loss. Managing nutrients is become a problem for many coastal managers, and people around the states are looking for ways to mitigate the effects of excess nutrients and to restore water quality. This includes implementing projects that are specifically designed to reduce and remove nitrogen. So there's a few things that we know when we think about water quality management and nitrogen management in particular. We know that land-based nutrient reductions are not really enough to keep up with the current amount of nutrients that are entering our waterways. And we know that wastewater treatment plants are costly, and they also might not be able to continue to keep up. As Kelly showed, wastewater treatment plants are already thinking about the next 10, 20, 30 years. But what we also know about nutrients is that it's really difficult to control and manage non-point source pollution of nutrients. When we have a wastewater treatment plant, for example, we can point to it and say, you are adding nitrogen. But a lot of the nutrients that enter our systems just are integrated from out the landscape. So it's really hard to say, to point to and say, you have done that, put in this much nitrogen to the waterways. This is where shellfish come in, because we know, there's a good bit of literature on this, that shellfish filter water and that shellfish remove nitrogen. And that's why there's this movement or interest in using shellfish for water quality goals. So I put together this little cartoon to walk everyone through what the connection is between our shellfish aquaculture and nutrient loads. So here we have sources of nitrogen to our coastal waterways. They're atmospheric, deposition, runoff, fertilizer use, etc. When that nitrogen enters the water, it then feeds algae. The algae are then grazed on by the shellfish because they're filter feeders, and then repackaged as their biodeposits. Their biodeposits end up on the sediments, and then they can be used by microbes. And through a process of a series of biogeochemical reactions, ultimately the nitrogen that fed the algae that's been processed by the shellfish can be converted into N2 gas through denitrification. And this represents a nitrogen removal, because this nitrogen is now no longer available in the system, and it's back up into the atmosphere where the majority of our nitrogen exists. The other way that shellfish can remove nitrogen is through assimilation into their biomass. So as these shellfish are out in the water and they're growing and they're filtering, they're also taking up the nitrogen in their shell and their tissue. So in our shellfish systems, we have then 4 fates of nitrogen. The nitrogen can be denitrified, turned into N2 gas, mineralized, recycled within the system, because we still need a little nitrogen, or it can be assimilated, stored in their biomass, or buried. So the goals of our project were then to figure out the nitrogen removal associated with Florida's shellfish aquaculture. We've been seeing or hearing for a long time about data from other areas, other states in the United States, but we were missing data from Florida. So we were lucky enough to get this funding to really get those data. And this is really important because shellfish aquaculture is growing around the state, and we're also up against a lot of water quality issues, looking for many solutions. The first part of our work was focused on identifying and quantifying what the nitrogen removal value potential was for shellfish aquaculture in Florida. This included two of the key ways that nitrogen is removed: through that assimilation at harvest, through accumulation in shell and tissue, and then through enhanced denitrification. Notice the word enhanced here, and that's because denitrification happens naturally in our environment. And so we want to make sure that what we quantify is what is excess or in addition because of the shellfish presence. We also wanted to then see if there was some predictive relationship to estimate nitrogen removal associated with shellfish, because quantifying, as you're going to see in a minute, and measuring all these nitrogen removal mechanisms is time consuming and difficult. And we can't always be all around the state taking these measurements. So if there was more of an on-farm method that we could do, that could really help move this, move the nitrogen removal crediting forward. And ultimately, we could use this information then to sort of to identify if there was some like default value that we could use, or in Tom's case, figuring out that offset that might be due to the uncertainty. So the first thing that we needed to do was figure out where to do our sampling. And to do this, we had three criteria. We needed water bodies that had active leases of both oysters and clams. We needed water bodies that had nitrogen problems, and then they needed to be within a 6-hour drive of Homestead, where our lab is based. And so in doing that, we identified two key areas. We have sampling locations in the Big Bend region up here, and then we have sampling locations down in the Tampa Bay region over here. We went out to these sites where they had both oysters and clams, and we conducted these samplings during the wet season and the dry season, because it's Florida and we only have 2 seasons. When we go out to sample, we take a whole group of people and we collect a lot of sediments, a lot of water, and a lot of shellfish. We then bring everything back to the lab and set our samples up in specialized equipment and then measure denitrification using a mass spectrometer. We have to start collecting our doing our incubations and measuring denitrification within 24 hours of collection, which is really why we wanted to make sure we had a 6-hour drive back to our lab, and it really limited the geographic extent and the number of samplings that we could do. So here are some of our results for our denitrification. This is a net N2 flux. So a net positive N2 flux means that there is a denitrification happening. The blue bars are the control sites or our background sites that didn't have any shellfish presence. And then the orange bars are from active shellfish farms. We have both the Southwest Florida sites and the Big Bend, and then our clams and our oysters. And just looking at this right away, I think there's some obvious trends that you might see. Number one, in the Big Bend area, our clams were not as high as the clams over in Southwest Florida. And we also start to see this in the Big Bend area. The shellfish farm doesn't always exceed the background in terms of their denitrification. While over in our Southwest Florida region, we do see this enhancement more often. This was really interesting to me as I've been thinking about these processes for a long time. And it was clear that there are really site-specific differences in our 2 locations that are probably contributing to the difference in the enhancement that we're measuring. These can be variations in the local hydrology, the sediment type. One site Southwest Florida is a little bit sandier than the Big Bend samples. And then also just the sheer number of farms. At our Southwest Florida site, there's one farmer who we worked with a lot, and there didn't seem to be very many other active farms nearby when we would go out and sample. Well, when we went to the Big Bend, it was clear that there was a lot of shellfish in that waterway. So it's possible that there is some connection between the shellfish biomass in terms of denitrification, and then also we just don't know really what the fate of the biodeposits are. So in these systems where there's a lot of shellfish, there just might be biodeposits all around that are leading to this increase in denitrification, even from our background signals. But collectively, these results just remind me that these are highly variable and that there is a real need for site-specific data. This is, I should have said this earlier, this is the average of all of our sampling events. So in addition to our denitrification, we have our nitrogen in tissue measurements, and we do this by measuring, weighing, grinding our shellfish. And so we can figure out how much is removed through harvest. And Shirley Baker's lab has been doing this. We have some preliminary data that's based on different size classes and different diploids or triploids of oysters. And you can see the general trend is that with more, the bigger the shellfish, the more nitrogen it has in it. We're still waiting for some final results from our different locations to see the importance of location within the total nitrogen in shellfish tissue and shell. So now that we were finally getting these data that were locally relevant to Florida, we were able to we wanted to see if we could predict a relationship. And this is some work that Giovanna has been doing, who's a master's student working on this project. And she compiled data from denitrification from shellfish systems. And there were 230 different studies or measurements that she looked at and wanted to see if there was a predictor that was easy to measure. And so what we looked at was then water column nitrate and sediment organic matter. And what we found is that neither one of these really worked at predicting our denitrification rates. Only about 8% of the variation in denitrification was predicted by water column nitrate or sediment organic matter. It was a little bit easier to predict nitrogen content in shell and tissue. That might be more promising as it's based mostly on the length of the shellfish. But these results, there's something else that's affecting denitrification rates that we would need to get a better handle on before we can have a predictive model. But that's not to say that we still can't use the data that we have to really that we've generated from this project to figure out how much nitrogen is removed by shellfish farms. And to do that, we will combine our denitrification enhancement data, converting that to a yearly value based on light, daily rates, light changes, and then scaling that to the footprint or the lease area. Well, to that, we'll add the nitrogen removal through assimilation at harvest, which is based on the nitrogen content in the individual, and then scaled based on harvest sizes. And with these two pieces of data, we can end up with the total nitrogen removal. And so I've done this, a little activity for everyone here to demonstrate like what would happen when we do actually upscale these data. Remember, we have the extraction numbers and we have our denitrification enhancement numbers. And so this is the average from the studies or from the results that we have so far. For our oysters, the extraction is about 0.12 grams of nitrogen per individual, while the denitrification enhancement in grams per acre per day is 9.74. Clams have a little bit less in terms of their extraction value, but a lot more in terms of their enhanced denitrification, giving us 43 grams per acre per day. We then can sum these values up and get the total nitrogen removal, which would be kilograms per year based on a 2-acre lease and 250,000 individuals of both clams and oysters. And we end up with about 37 kilograms per year of nitrogen removal due to oyster presence and 49 kilograms per year of nitrogen removed due to clam presence. To give a little bit more context to these numbers, I've converted this then into pounds of nitrogen. So if this was our lease, for example, it would remove 190 pounds of nitrogen or 23 50-pound bags of lawn fertilizer. In this case, this would be a potential payment to a shellfish farmer of $78 to $877 based on the data that Kelly has been generating. Now, this payment might not seem like a lot, but if it's a chance to get some extra revenue for doing something you're already doing, I think that it still has a potential value there. So now that we've been able to get these locally relevant data for Florida's shellfish farmers, we've been able to update the green clam calculator on Leslie's website, which some of you might have used before. And I want to take you guys there now. Because what we really want to do is figure out what is the potential payment for services that one could have. So we have this, we've created this calculator to get that estimate for everybody for their farm activities. I'm going to switch screens now and take you there and take you to our calculator website. And Leslie, I'm hoping that you'll hop on and help me demonstrate how we can use this calculator. Oops.
Okay, I'm on board.
Great.
Yeah, it's a very simple and utilitarian calculator. We're only asking the growers for a little bit of information. And so let's get started, Ashley, if you want.
All right, can you guys see the website? Okay.
Yeah, we see it.
Perfect.
So
Leslie,
we're going to look at a clam farm.
All right.
In Cedar Key. All right. And let's
How big is your clam farm?
6 acres of a commercial clam farm. And so then you're going to hit next. And, oh, geez. All right, the number of clams harvested per year, let's go ahead and say 900,000 clams were harvested from that 6-acre farm.
Much better than my little farm.
Yeah. Well, that's pre-Idalia. All right, and then the calculations allow you to look at the nitrogen removal and value from your farm in that 1 year. And let's look at these values real quick. So 139 pounds of nitrogen removed from your harvest, 207 pounds of nitrogen removed through the denitrification process over the year. And then finally, the value of those services estimated at $637. Now you look at the tabs on the right where you can learn more about the values that were used in the calculator and more about how they were developed and what this all means.
Just load that now.
There you go. Yep. So there's the payments, average payments for those services based on kilograms per acre per year, right? Yep, dollars per kilogram, excuse me. Again, a schematic on denitrification and the values obtained from Ashley's work on this project, both for clams and oysters. And then from Shirley Baker's work looking at the nitrogen removal through harvest and then the value of nitrogen content in clams and oysters, both shell and tissue. So let's go do an oyster farm real quick if we can. So you can scroll down and click back to retake. And let's do an off-bottom oyster farm.
It doesn't like those. It wants to, it needs a sec to load.
Oh, it does. Yes.
Okay.
All right. Now we're going to look at an oyster farm. And let's do 4.5 acres in Oyster Bay in the Panhandle. And let's harvest, well, let's go ahead and do 100,000 oysters harvested over a year from that farm and look at what those values are. And we see 27 pounds removed through harvest. And we scroll down and 35 pounds removed through the denitrification process, and the annual monetary value estimated at $114. So that's based on the scale of that particular operation. You can also find the links to where the calculator can be found. And I think that would take us to, let's look and see what last year's production, both oysters and clams statewide, what that produced in terms of, we'll have to share the screen on the infographic slides. So we looked at last year's production, obtaining data from DAX and the total acreage of bottom aquaculture leases statewide, and plugged in all these values that have been generated through this project. And you can see the amount of pounds of nitrogen removed through harvest, enhanced denitrification for Florida hard clam aquaculture, 53,000 pounds, and then the economic value of those services estimated at $126,000 And that represents the ecosystem benefits that clam culture provides to our citizens, to the public, at no cost. We did the same for oysters statewide. Last year's production, as well as the amount of water column leases and acreage in last year. And again, using the calculator, we came up with close to 1,000 pounds of nitrogen removed through harvest of the 3.8 million oysters, close to 4,000 pounds of nitrogen removed through denitrification, and the economic value of those services estimated at just shy of $9,000. So I think that's it. Again, the calculator is posted, and I believe that you will see that in the chat, as well as information that you get post-meeting as to where you can find this calculator and play around with it yourself.
Thanks, Leslie. The QR code's up here if anyone wants, or QR codes if you want to scan it and start playing now. So with that covers my section of the talk of our sharing with information about the nitrogen removal benefits that we've been able to calculate for Florida's shellfish aquaculture industry. I'd be happy to take any questions.
So we've got a question in the chat, Ashley, from Tim. I don't know the life history of a clam or oyster, but if the planted area is a no harvest area, would the ecosystem service benefits be more long-term, or would they be just as limited as if they had been harvested?
So if you're going to plant your, if you're going to plant your clams or oysters in an area that's closed for harvesting, that would be more in a restoration context. So in that way, you're going to be looking more at the denitrification benefits than necessarily the extraction service, because you want your clams and oysters in there because you want the water quality benefits. So, so in terms of like what you would be getting the value from, I would rely more on the denitrification.
And Ashley, how long would that clam be denitrifying?
Oh, they need nitrify like all the time.
No, I mean, how long does the clam live? So
yeah, I think the fate, like you have to account for some of the shellfish not making it, right? And then that's like a recycling, that nitrogen stays in the system and is regenerated and recycled. And so again, to what you were saying, Tom, earlier about figuring out like what are the uncertainties and limitations? Do they continue to denitrify when they grow? Is it these conditions in the environment that are supporting them? There's still a lot of unknowns that I think we really need to dive deeper into. And if anything, this study has really showed some of what those unknowns are and where we should go next.
We've got another question in the chat from Matt. Can you discuss more why you think you saw greater denitrification at oyster farms compared to clam farms in the Big Bend region?
I think Leslie could check me on this, but I think it has to do with the location of where the clam and oyster farms were in the Big Bend region. The clam farms, they're in the water, in the soils and the sediments, and so they're generally in areas that are more sandy, while the oysters are in the water column, and their bottoms would be areas that clams don't go. And I think that accumulation of organic matter is really what the difference could be.
I'm going to ask a quick question. Ashley, I know we've talked about this a lot, but we're focusing today on the nitrogen removal capacity for shellfish, but thinking about some of the other ecosystem services that shellfish provide, and assigning a value to that, things like increased water clarity. I just wanted to know if you wanted to end on that note as well.
I think that that's an important point, Angela. Like we've talked a lot about just the nitrogen removal benefits of shellfish aquaculture, and having shellfish in the environment does a lot of great things. It's not just removing nitrogen, they're filtering water, they're providing habitat. And when we think about their total value that they're providing in ecosystem services, all those other aspects should be considered too.
I've got a question, Ashley. How different is this from the figures that people are getting in the Northeast and elsewhere? Are we similar, or is there an order of magnitude? How different is Florida?
Yeah, that's a good question. So the numbers that we've gotten from the Southwest Florida region are on par with what I see before for some of my own work. And even like the oysters in the Big Bend. What we've seen from our clam work in Virginia tends to be clams lower than oysters. So I think that we use a different method there, so it's not directly comparable, but that sort of fits that narrative that we've seen before.
So it's 3:29, which I'm so impressed with all of us that we did a very good job staying on time. Good job, speakers. I'm just going to do a clapping so you can hear me. And I want to remind all the participants that we will be forwarding all of the information, including the Zoom link or the recording, the Zoom recording, so that you can watch this as many times as you like. But before you jump off, we will be very thankful if you could take a quick poll. Just easy questions that only take a couple seconds. And if there are any lingering questions, please feel free to throw them in the chat, as I see that Ed Sherwood just did. Ashley, can you see the chat there from Ed?
Yeah.
He says, what FDAX restrictions would need to be considered?
Payments for services were sought in non-approved shellfish waters. I think that that's a good question. Tom, that might be a you question.
Yeah, well, they just approved just a couple of years ago. Tim Rock's here too, if he wanted to chime in. They just approved a program to allow this to happen, but it happens in a sort of a pilot basis using not-for-profits and academics who are allied with clam farmers to allow them to harvest outside of approved shellfish waters. So I guess the converse of that is that it's not currently permitted except through that mechanism.
Along those lines, the last part of the question is there a certain amount of time that FDAX would require if you move those shellfish back into conditionally approved shellfish waters for them to subsequently be harvested and reap additional nitrogen removal credits?
That's a good question. That's maybe a Leslie question. It's a public health question.
That is considered relaying and would not be allowed to go from unclassified or prohibited classified waters back into approved waters or conditionally approved. There's not a mechanism allowed for that.
I think it's worth knowing, correct me if I'm wrong, Leslie, but you can have excess nitrogen and phosphorus and have approved shellfish waters. It's fecals and other issues, other pollutants that are more of a problem. Is that right?
Yes, but I thought the question was if you were located in a
No, it is
a restoration farm, but yes, yeah, the only thing that's monitored to meet national standards for shellfish sanitation is fecal coliform. Correct.
Does that help, Ed?
It sounds like if that's the only consideration, if fecals is the only consideration for harvest, then having a certain amount of quarantine time in a conditionally approved site might be necessary to kind of reap these credit benefits in areas where restoration needs are paramount.
And if I recall, some of the issues with getting shellfish waters approved is a question of monitoring. It's not a question of whether the water quality is there or not. It's just that there's rigorous protocols for monitoring that are expensive and time consuming. And if the demand isn't there, they don't do it. Is that also true, Leslie?
That's correct.
Yeah.
All right. Well, everybody's thank you so much for your time and attention today. I think that we all learned a good deal. Stay tuned for a follow-up email from me containing all of the links and resources that we heard about today, including all of our presenters' contact information. So if you do have questions that you think about later, feel free to contact any of the project team. Reach out anytime. And I think that this is just the beginning of a really exciting era in shellfish aquaculture and research. So there's a lot more to keep coming. Any final words from our project team? Ashley, you wanna end it?
Thank you all for your time and attention. And I do want to say that I did not acknowledge Gabby Forza, who has been instrumental in all of the work that I talked about today, and even in the creation of our calculator. So special shout out to Gabby for all that she's been doing for this project. And stay tuned. There's a lot more to come, including moving into seaweed.
Okay, awesome. Well, thanks everybody. If there are no further questions, I will officially end the workshop only 4 minutes late.
Thank you.
Thank you. Goodbye.